Here is something that happened recently that completely changed how I think about debugging production systems. An engineer wrote a simple prompt to an AI agent. Investigate the latency spikes in the front-end service that happens every 4 hours and tell me why. 8 seconds later, the AI agent had traced the issue through 3 microservices, identified the exact method call causing the problem, and explained why it was happening. The cost? 60 cents. This wasn't some custom trained model or expensive enterprise solution. This was Cloud Sonnet connected to an observability platform through Model Context Protocol. In this video, we are going to cover what observability actually is and why every distributed system needs it, how AI agents are fundamentally changing the way we debug production systems, and how tools like Honeycomb are connecting LLMs directly to your telemetry data so you can investigate issues in seconds instead of hours. Big thanks to Honeycomb for sponsoring this video. Let's get into it. Let's start with the basics. What even is observability? Imagine you are running an e-commerce site. A user clicks checkout, and behind the scenes, that single click triggers a cascade of events. The front-end service talks to the cart service, which talks to the inventory service, which talks to the payment service, which talks to the shipping service, which all talks to various databases. Now imagine a user reports that checkout is slow. Where do you even start looking? Which of these services is the bottleneck? Is it the database, the network, a specific piece of code? And this is the problem observability solves. Traditionally, we have had 3 tools to understand what's happening inside your systems. Starting with logs. These are timestamped record of events. Think of them as a diary your application writes. User 12345 clicked checkout at 2:15 p.m. Payment processed at 2:15:03 p.m. Or error, timeout connecting to shipping service. But the problem with logs? When you have millions of requests per day across dozens of services, finding the relevant log entry is like finding a needle in a haystack. Then there is metrics. These are numerical measurements over time. CPU usage at 45%, memory at 2.3 gigabytes, request latency P99 at 250 milliseconds. Metrics are great for dashboards and alerts, but they are pre-aggregated. You decide in advance what to measure. If you didn't think to track latency by discount code type, you can't go back and ask that question. And finally, traces. A trace follows a single request as it flows through your entire system. So when that checkout request hits your front end, a trace is created. As the request moves to each service, that trace collects timing information, metadata, errors, everything. At the end, you have a complete picture of that one request journey. Each segment is called a span. The front-end span took 450 milliseconds total. Inside that, the cart service span took 50 milliseconds. The payment span took 380 milliseconds. Now you know where the time went. Now, the industry has standardized on something called OpenTelemetry, or OTEL, for collecting all this data. It's an open source project that gives you libraries for every major language. You instrument your code once and you can send traces, metrics, and logs to any observability platform. So that's the foundation. You instrument your services with OpenTelemetry, and that telemetry data flows to an observability platform. And engineers can query that data to debug issues. But here's the thing. This entire model was built with one assumption, that humans would be the ones analyzing the data. For 20 years, observability tools have been solving one fundamental problem. How do we make terabytes of data comprehensible to human beings? Dashboards, alerts, log search interfaces, these are all compression mechanisms. We are talking thousands of events per second and squeezing them into something a human brain can process. But humans can only look at so many graphs. We get tired, we miss patterns. We can only hold so much context in our heads. Large language models can consume and interpret data at scales we never could. They don't get alert fatigue. They don't forget what they looked at 10 minutes ago. They can generate hypotheses, test them, discard them, and try new ones, faster than any human engineer. And this changes everything about how observability tools should work. Here's the equation that's reshaping the industry. OpenTelemetry commoditized instrumentation. Everyone can emit traces and metrics the same way. LLMs are commoditizing analysis, and AI can look at your telemetry and extract meaning from it. So, what's left? What's the actual competitive advantage for an observability platform? Speed, the ability to return results fast enough for AI agents to iterate quickly. Now, some of you might be thinking, if AI can write code and debug code, maybe observability becomes less important. Actually, the opposite is true. There is a concept I want to introduce: disposable code versus durable code. Disposable code is the stuff AI generates easily and cheaply. Prototypes, scripts, experiments, one-off data processing jobs. You generate it, you use it, and you throw it away. But then there is the code that runs the world. Banking systems, payment processing, medical records, shipping logistics. This is durable code. It can't just be regenerated when it breaks. It has contracts and dependencies. When it fails, real money is lost. Real people are affected. And here is the key insight. As AI generated code floods into code bases, the complexity of durable systems increases. Alright, let's get to the technical details. How does an AI agent actually debug production systems? And there are three components that make this work. Component 1, OpenTelemetry instrumentation. Your services need to emit structured telemetry, traces that capture the flow of requests through your system, spans that capture timing and metadata for each operation. This is the raw material for any investigation, human or AI. Component 2, a fast query engine that handles high cardinality data. Traditional monitoring tools work great when you are grouping by predefined dimensions, by service name, by HTTP status code, or by region. But the insights that actually solve the problems often require grouping by high cardinality fields, by individual user ID, by specific session token, by a particular feature flag combination. Honeycomb's database was purpose-built for this. Sub-second queries on arbitrary dimensions even with massive cardinality. Component 3, the Model Context Protocol or MCP. This is the bridge between AI agents and your observability data. Think of MCP as a USB port for AI applications. It's a standardized way for AI agents to connect to external data sources and tools. Honeycomb's MCP server exposes tools that let AI agents query datasets, run anomaly detection, access SLO data, inspect individual traces, and create visualizations. And you can use this directly from your IDE. Cursor, VS Code, Cloud. You can ask questions about production while you are writing code without switching context. Let me walk you through what an actual AI investigation looks like. Picture a heat map showing request latency over 24 hours. There are spikes that happen roughly every 4 hours. In a traditional workflow, you would start clicking around, forming hypotheses, manually running queries. With Honeycomb's Canvas, their AI-powered investigation workspace, you can just ask, why are these latency spikes happening every 4 hours? The AI first queries the overall latency distribution across all endpoints. Then it groups by route to see where the latency concentrates. It finds that checkout is the problem area. Now it runs Bubble Up, Honeycomb's automatic anomaly detection, to find what's different about the slow request versus the fast ones. It discovers that slow requests all have a specific discount code pattern. It drills into the checkout service, then follows the trace downstream to the discount calculation service. Root cause identified. The discount service is making up too many database calls for certain promotional codes, causing timeouts that cascade back up to the front end. Total time, about 90 seconds. Total cost, less than $1. Compare that to the traditional approach, waking up at 3 a.m., opening 4 dashboards, scraping through logs, Slack threads, eventually maybe finding the issue 3 hours later. And here is where this is heading. Right now, we are in the co-pilot phase. You ask questions, AI investigates, and you verify the findings. Next comes proactive monitoring. AI agents watching your systems in real time, catching anomalies and surfacing issues before customer notice. Eventually, we'll see autonomous agents that detect, investigate, and fix problems with human approval. On-call engineers become supervisors, not firefighters. Teams building for Phase 1 now will be ready when Phase 2 and 3 arrive. Getting started is straightforward. First, instrument your services with OpenTelemetry, because without structured telemetry, AI has nothing to work with. Second, send the data to platform built for AI speed queries. Honeycomb has a free tier with 20 million events per month. Link in the description. Third, connect your IDE through MCP. Cursor, Cloud Desktop, VS Code all work. Fourth, start asking questions about your production systems. Here is what I want you to take away from this. Observability isn't becoming obsolete in the AI era. It's becoming the foundation that makes AI-assisted development possible. If you want to explore this yourself, check out Honeycomb, link in the description, free tier available, no credit card required. And also let me know in the comments, are you using AI for debugging yet? And what's your experience?